electrode deposition. 是你对那个什么电路有兴趣是吗？
自己有兴趣。
什么？
自己有兴趣。
你说什么？
说自己有兴趣。
你不是有兴趣，就是你要做，是吧？
对。
哦。行。我们上次讲你好像没来，有录影，完你可以要去换剧情。So electrode deposition, we started talking about the mechanism for last time, okay? And so we're going to continue, okay? So electrode deposition. I'm going to try to write a little bit better, okay? Electrode deposition. Okay, so this is on page 503. Okay. So we talked about process. Okay. So we have metal ions in solution. Okay. So this is a cathode. Okay. Okay, so this is the cathode. Okay. So when we close the circuit, right? So this is power source. Okay. So once we turn on the power, right? This is the cathode. This is the anode. Metal ions are going to dissolve, and the electron is going to go from the anode to the cathode. Okay? And drive this process of electrode deposition. Okay? This is a non-spontaneous process. Non-spontaneous. Okay? It means that it's power intensive. Require power, right? So when you turn on the power, right here, right? Electron is going to flow, okay, to the surface, right? And the metal ions, okay, this is solution is going to see the metal ion because it's positively charged, right? It's going to see that the surface of the cathode is being negatively charged. And so it's going to deposit on that surface. Right? Because this surface is negatively charged. This metal ions is going to deposit on that surface. Right? And so we talked about this. So once it deposits on the surface, right, this becomes metal azure. Azure, okay? This is metal. Okay? This one have the metal aqueous ion that deposits on the surface of the cathode is going to have, okay? And so this is M plus azure, okay? And then once you get deposit on the surface, right, it's gonna, it has two options, okay, based upon the voltage, okay, it has two options, okay. So it has two options. Okay, they can either congregate. So congregate into clusters on the surface. Okay. 我画的不是特别好，就是画一下。Okay. So if there is sufficient number of atoms on the surface that they're near each other, okay, they can bunch together and form a nucleus. Okay? Nucleus. Or they can travel to the this is called a king. Okay? They can travel to the periphery of the crystalline structure and deposit at the king site. Okay? So it has two options. The first option is incorporation. Into king. New kings as part of a lattice. Okay? At the boundary. Okay? To lattice. This is i.e. crystalline boundary. OK， 这个就是它的那个晶体的边缘。在这晶体的边缘，是吧？它落在那里的时候，因为它周边已经有形成这个晶体了这个金属原子它的那个什么它有一个特定的这种orientation 是吧？它一旦落入这个 king， 它跟它旁边周围的金属原子会形成一个比较稳定的状态，就是一个不同的金属不同稳定的金子的状态，是吧？它就这是一个方式啊。第二个方式呢是它周围有足够多的这种 atoms 在晶体的表面，是吧？它可以聚在一起，形成一个 nucleus。Okay? So the second option is formation of a cluster. Okay? So these are the two options for electro deposition. Okay? But note that this incorporation into the king at the crystalline lattice boundary. Okay? This is a 2D process. 这是往这样子，是吧？如果这个东西这是 nucleation， 是吧？As nucleus. New nucleus. Okay? If the conditions are sufficient for nucleations to happen, such that more and more of these atoms cluster together on the surface. Okay? This is a 3D process. So, 这个 nucleus 的形成并不代表说这个二维的东西会停止，它也会发生，就是它既是发生在平面上，在这个晶体的周围，也是发生在晶体的表面。OK， 所以是一个三维的这种就是晶体的形成方式。对于这条件下，这是一个不能，这就只能发生在这晶体的周围。So So deposition can be either 2D or 3D, okay, depending on conditions. As conditions is on the surface potential, okay? So if surface over potential increased to a certain amount, okay, the nucleation will dominate, okay? If it's not, if it's less than that threshold surface potential, then electrodeposition that happens at the key is going to dominate, okay? So as potential increase, okay, the growth rate of ED increase, okay, and nucleation increase, okay. So if the kinetics of the constant of the nucleation, okay, is less than the kinetic constant for the growth of deposition, then fewer nuclei. Fewer nuclei. Okay. And the electron deposition will lead to larger grain size. Okay. If the nucleation constant is greater than the growth, okay, deposition, then larger nucleons, larger, larger number of nucleons. So this will lead to smaller grain size. So you have a picture in your book, okay? 这个是可以在 S 键下面可以看得出来。13.2是吧？就是so so for example lychee, right? Smaller, and you get like smaller grains of electron depositions. Okay? But if you do have larger current density, right? Then you have larger grains. Oh, sorry. Small, larger grains. So nucleation, okay, or in other words, formation of new cluster. Can only grow if critical size is reached. Critical cluster size. So nucleation, nucleation is proportional to delta G. It gives the energy. Okay? So what I mean by this, okay? So delta G, okay, is a function of the number of cluster size, okay? So which is equal to minus m z cubed potential s plus b. Okay? So this is the change in electrical energy due to change in potential, okay, between solution and metal. Okay? Whereas this second part is the excess energy. Okay? Associated with formation of cluster. So this is always positive. Okay? This is always positive. This is always negative. Okay? So if you look at this term, right, there's excess energy associated with the formation of clusters, right? This P, okay? P of N, okay? So for example, okay, for three cases, okay, we're talking about nucleation, right? So if this nucleation is 3D 如果是 nucleation 的话，它是同时往上还有往横的方向长，所以是3D So Vm is equal to AS, yeah, okay? So this AS is the surface area of the electrodeposited whereas this gamma is the average specific energy. Okay. So the area, right? Area is a function of F. Okay. So and volume, okay? Volume of the cluster, right? BC, okay? Your book has a notation like this, so we'll use the same. Okay? Volume of cluster, okay? So volume, this is volume of the cluster. Cluster. This is equal to V. Yeah, times that. Okay. So, for example, okay, we have a cluster of four atoms. Okay. This volume, right, of the cluster, right, is the volume of the individual atom times 4. 这个 cluster 主要是4个 atom 组成的，所以如果你要算它的这个体积的话，那就是每个 atom 的体积乘以4。Okay. So this is equal to Vm times 2. Okay. Whereas this AS, okay, the specific surface area of this cluster, right, this is proportionate to the volume. Okay. So this is the total surface area. Total surface area. Of the cluster, okay? This is the total surface area, total volume, total, T-O-T-A-L, total, okay? Total volume of the cluster. Okay? So we wanna relate these two, okay? 我们想把这个cluster 它的这个表面跟它的这个什么体积联系起来，是吧？So if you look at the unit for this, right? This is the area is length squared, right? Whereas the volume is length cubed. Okay? So the reason, the way to link the area to the volume together is to multiply, or not multiply, is to the way to link these two together, okay, is to cube the area and square the volume. Okay? So with E being a constant. example, for a spherical geometry, okay? Spherical geometry. Let's- if you have a cluster that looks like this, yeah, a spherical cluster that looks like this，你电路的时候啊，有些时候会形成那种球状的东西，知道吗？So for this spherical geometry, right, if you want to relate its area to its volume, right, you have to cube the area and square the volume, okay? And these two are related with the B constant, okay? So AS cubed is equal to BB squared. Okay? So solve for this B, you get B is equal to AS cubed over B squared. Okay? So for a cube, okay? For a cube, right? I mean, not for a cube, for a sphere, okay? The area is 4 pi r squared. Whereas the volume, right? Volume of the sphere, okay, is equal to 4/3 pi r cubed, okay? Right? So we put this here, and here, right? You solve for B, right? So B is equal to 4 pi r squared cubed over 4/3 pi r cubed squared. Is equal to 36 pi. So the reason why we're doing this, right? We wanna this excess energy, right? This excess energy associated with the formation of a cluster, right? We wanna. This is a surface area dependent parameter. Okay, we want to convert this into a volume dependent parameter. Okay, so using this, okay, so Vn is equal to ASM, right? Which is equal to and this so this AS cube is equal to V squared, right? And we calculated what this B is, right? So AS is equal to cube root of BB squared, okay? Which is equal to B to the 1/3 and B to the 2/3. So which is equal to this 2/3. Down. And this V here is equal to the volume of the individual anions times N. Okay? Right? So you put this here. Okay? You get V of 1/3, V and 2/3, and the 2/3 times M. So this is 13.7. Okay. This is for a spherical for a spherical nucleus. Okay. So he gives free energy as a function of the number of n of the cluster is equal to minus n, right? Z cubed absolute potential plus V n. So this is the 3D case, okay? You put this here. You put this here, right? So you get this is equal to minus n Z cubed plus V to the 1/3 Vn to the 2/3 times n to the 2/3 times m. So this is 13.8. Okay. So Gn, okay, he gives free energy as a function of Gn, right? The number of cluster, number of atoms in a cluster, okay? That is this, okay? So if you plot this, okay? If you plot this, right? G is a function in n. Okay? You get a curve that looks like this. Okay, this is 0 and goes like this. This has a behavior that looks like this. Okay? There's a maximum. Okay, that's associated with for a different surface potential. Okay, so this is minus 25 millivolts. This is minus 30 millivolts, and this is minus 50 millivolts. So you can see, right, as the overpotential increase, right, or the magnitude of the overpotential increase, right? So as this increase, okay, the absolute overpotential increase, right? The curve changes, okay? So this right here, right? If you if you take the derivative of the Gibbs free energy as a function of the change in n, this uppermost point, right, corresponds to the point where dg dn is equal to 0, right? And this point here is anchored. Okay, so this is the critical number of atoms, okay, in a cluster for that cluster to be stable. Okay, so at different overpotential, we can see that the just as so anchored, right, this is the number of atoms, okay, per cluster to be stable. Okay? Okay? So in other words, i.e., okay, for nucleus or nucleation to continue to grow. 这什么意思呢？就是每个这个什么 overpotential 是吧？它有一个特定的这个什么n 这个 n-crit 是吧 ？n-crit 就是临界的这种阀值跟这个就是atom 的数量是吧？在一个cluster 里面，然后达到这个阀值，就是 nucleation 才会稳定 ，nucleation 才可以就是持续的发展下去比如说在这个-25的时候，这个值是83，是吧？这是83。但是呢，随着这个什么 overpotential increase 的时候，到50的时候，这个值就到了10。所以你的这个 overpotential， 你 apply 的 potential 越大，它所需要达到这个稳定的这个 n-crit 的这个值越小。OK。So as overpotential increase, right? Delta G decrease. You can see it, right? As overpotential increase, right? 当这个值变大的时候，这个 delta G 就变得越来越负了。这个临界点是这个比这个还要大的时候是在这个 n-crit， 就是这个意思。Okay. So as overpotential increase, delta T decrease, okay, and cluster becomes more stable. Cluster become more stable. And fewer n. Okay? So, you can work out this number, okay? So, ancred at 3D okay, is equal to so you take the derivative and set this equal to 0, okay? We're using this equation, right? And then you put b here. Okay, and put this b here. This is for a sphere, right? You put it here, right? You take the derivative and set it to 0, okay? So you take the derivative of dgen and set it to 0 after you put b here, okay? And you solve for this equation, okay? For n, okay? And so you get this. This is equal to a b vm squared gamma cubed over 27 z cubed over potential cubed. Okay? This is 13.9. Okay? This is for the 3D case. Okay? And so the G-trip, or I'm sorry, the Gibbs energy at anchor, okay, you take this anchor, okay, you put it in this equation, okay, and solve for G, okay, you can find out this one. Yeah. So G crib is equal to minus n crib is z times q over potential plus 1/3 Vm raised to 2/3 gamma times n crib. Now, you just replace this n with n crib. This is n crib to the 2/3. Okay. So you put this n crib here, right? Now, and you get this G crib, G of n crib is equal to 4 b Vn squared gamma cubed over 27 z cubed potential cube, which is equal to n crib So this corresponds to this point. This corresponds to this anchor. Okay, so these are anchored. Anchored at different surface over potential. Okay. 这个 anchor 的意思啊，就是你的 cluster 在某个特定的电压的情况下，它需要达到那个数值，它才会稳定，就是 nucleation 才会继续下去，是这个意思。为什么你要知道这？就是在某个特定的电压的时候，你可以用这个来预测你的 nucleus 你 nucleation 的它的直径会达到多少。So this is for 3D, okay? This is for 3D, yeah? I'm not going to do the same for 2D, but 2D is the same, okay? So GM, geometric, okay? For 2D is the same, okay? It's minus M CQ over potential plus Z epsilon square root of B omega M. This for 2B, okay? And so anchor is equal to B omega epsilon squared ZQ surface over potential squared. So you put this in here, okay? Here, okay? You get G curve. Delta G curve. Is equal to B gamma epsilon CQ for potential, which is equal to anchor CQ observed potential. So what this means, okay, what does this mean, okay? So this means this, okay? If this is the nucleation rate, this is nucleation rate. Versus volts.就是它要达到这个 critical over potential 的时候，它才会开始。OK， 的意思就是这样，你的这个电压需要达到一个临界点，它才会开始产生这种比较细小的这种晶体的这种颗粒，在电路的时候，如果没有办法做到这点的话，那是不会产生。 So, so nucleation, okay, is a function of delta G trip. Which is proportionate nucleation. It is proportionate to J. Which is the rate of rate per area. New platform. On surface. Okay, so this J is the nucleation rate. Okay? So this is equal to A naught. That's right here. So J is proportionate. J is proportionate to A naught times exponent minus delta G trip over KT, which is equal to this has a unit of 1 over centimeter squared per second. So this K is the Boltzmann's constant. A naught is the constant. So using the delta G that we calculated previously, okay, for 2D and 3D, okay, we put this delta G 2D, 3D into this, okay. We get the nucleation rate is equal to A 3D exponent times 1 over KT. 4B. We put this delta G, okay, we put this delta G, okay, here, okay, and this up here, okay. So we get 4B Vm squared gamma cubed over 27 Z cubed total potential squared. And so this is the 3D case. Okay? And the nucleation rate for the 2D case, that is times exponent minus 1 over KT for B omega epsilon squared Z cubed potential KT. This is the 2D. So you can predict the nucleation rate based upon the potential, okay? The temperature, okay? So the temperature, okay? So and the charge, okay, and the from here, right, as potential increase, right? Because there's a negative sign here, right? As the potential increase down here, exponent of something that's negative, right? This becomes more negative. As this increase becomes more negative, this increase. So as over potential becomes more negative, the nucleation 2D and nucleation 3D decrease. So, so the nucleation rate, 2D and 3D, okay, is not a function of time. Okay? 你可以看到从这两个这个公式里面是没有时间，是吧？没有时间。So it's not a function of time. Okay? So this is because that as if potential is less than the critical potential, okay, the nucleation rate is approximately 0. Okay, this is what this means. Okay, if the potential is less than the critical potential, no nucleation will happen. Okay? So only when the potential is greater than the critical potential, nucleation happens. So if nucleation doesn't happen here, then the growth happens. EE continue. Okay. So this is like a two process. And if the potential is greater than the critical potential, then nucleation happens. Okay? Happens. So it's like this. Okay. 今天我们就讲到这好了。